All right. We're going to learn what mutually exclusive events are. Two events are called mutually exclusive if they cannot happen at the same time. Here is an example. And you tell me if you think this example represents mutually exclusive events or not. Event A. Select a female student with blue eyes. That's for first event. Event B. Select a female student or select a student. I'll write it down. Who is a nursing major. Can those two events happen at the same time? If yes, then the events are not mutually exclusive. Is it possible to find a female student with blue eyes who is a nursing major? Yes or no?
Yes.
Yes. Well, if your answer is always a yes, that means the events are not mutually exclusive. Okay, let's show you some more examples. It's in the book. I'm gonna get the book here and project it and give you some more examples. If you need the page number, guys, it's page 162. Okay. Number 7, guys, is an example of mutually exclusive events. And can you tell me why? How can you tell right away? By just glancing at the figure, you can tell right away that these are not mutually exclusive events. Why? Lost the popular vote. This is the first event. Won the election. Do they have anything in common here? Do you see that they meet, they overlap somewhere? Once they overlap, that means they have something in common. That means they can happen at the same time. So it is possible for a presidential candidate to lose the popular vote, but still win the election. Well, if this is the case, then they're not mutually exclusive events. But look at this, guys. Number 8, you can see number 8, there is no intersection whatsoever. If a movie is rated R, it cannot be rated PG-13. So that's why they don't have anything in common. These events are mutually exclusive events. Okay, let's go to number 9. What do you think of 9? Event A, randomly select a female public school teacher. And event B, randomly select a public school teacher who is 25 years old. Mutually exclusive or not mutually exclusive? In the chat. Not mutually exclusive, I do agree, because it is possible to find a female public school teacher who is 25 years old. If you can't, that means they are mutually exclusive. What about 10? Mutually exclusive or not mutually exclusive? That should be an easy one. Give me some feedback, guys. They are mutually exclusive. You cannot find one person who has a birthday in April and May at the same time. That can't happen. You cannot be born twice. Okay, 11. Just do one more. Randomly select a person who is a Republican and randomly select a person who is a Democrat. Can you find one person who is both a Republican and a Democrat? Yes or no? You can't. You cannot. That's illegal to apply for both parties. You either believe, just in Republicans or Democrats, so they are mutually exclusive. Okay, so that should give you an idea about mutually exclusive events. There will be probably one question on the test, guys. I'll give you 2 events and ask if they are mutually exclusive or not. So be prepared, just for a question like this. Okay, we have one more rule in section 3.3 that I'm going to introduce to you. It's called the addition rule. And then after that, we'll have one more objective when we'll be done with chapter 3. So there is not much. Let me tell you about the addition rule. I'm just going to do it through an example. Okay, let's say I have a sample space that has all the outcomes. It has numbers from 1 to 15, let's say. 6, 8, 9, 10, 11, 12, 13, 14, 15. So that's my sample space. It's all the outcomes. And let's say I have an event A that has those outcomes in it. That's A. And let's say I have another event B that has those outcomes. And I'm going to ask you a few questions, guys. What is the probability? First question. What's the probability of picking a number at random and this number turns out to be in A? So you just close your eyes. What's the likelihood that you pick a number in A? Just like I did now. And you guys tell me what the probability is. Yes? So the definition of the probability, guys, is the favorable outcomes divided by the total number of outcomes. How many are in your favor? In your favor means belong to A. Count how many are there in A. Let me see what some students said here. 6 out of 15. Okay, let's see. I got 1, 2, 3, 4, 5, 6. Yes. And 15 altogether. I said that I have 15 values. Yeah, that is correct. Question B, guys. What is the probability of selecting a number that number turns out to be in B? Denominator never changes, guys. I have 15 data values. And I see a 16 again.
6.
Yes, yes, indeed. Great. C. What's the probability of selecting a number from in this sample space and this number turns out to be in A and B at the same time?
2.
2 out of
15.
Does everyone agree why 2, guys? This is 1 and this is another 1. So it is 2 out of 15. Okay, last one, which is the new stuff that I'm trying to introduce. What is the probability of selecting a number that you would win if this number in A or B? It doesn't matter whether it is in A or B, as long as it is one of them. So that's 15. Let's count how many are in A or B, guys. You got 1, 2, 3, 4, 5, 6. Do I need to go back and count those two numbers one more time, or I can't, guys? Yes or no? You can't. That's correct, Julia. You cannot. Just like if I'm taking attendance, if by mistake I count the number, I wrote a student's name twice, it doesn't mean that when I figure out how many students were present that I can add this name twice. That would be wrong. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a probability of A or B, which is 10 over 15. But I'd like you to notice something, guys. If you added the 6 with another 6 here, which is going to give you 12, and subtracted the 2, you were going to get 10 over 15. And this is called the addition rule. So I'm going to write a formula for the addition rule. Probability of A or B, guys. It is a probability of A plus probability of B minus probability of A and B together. This is called the addition rule. All right, so this is a formula that demonstrates the addition rule. Every time he asks you to do an event or another event, you find the probability of the first event plus probability of the second event, and you minus the probability of those two events happening at the same time together, and you get the answer. And this is the formula right here. It's right here, guys. That's the rule. Now it says here, if the events A and B are mutually exclusive, then the probability of A or B equals probability of A plus probability of B only. Without this, why is that, guys? Why, if the events are mutually exclusive, we don't count the probability of A and B?
Because they can't happen at the same time.
Yeah, they cannot happen at the same time. They don't have anything in common. It will be something like this, guys. A and B, mutually exclusive. Watch. It would be something like that. Nothing in common. So probability of A and B is going to be 0. So if A and B are mutually exclusive, I'm going to put probability of A and B is 0. Oops, I'll write it here. Equals 0. Well, you know, it's not the case here, guys, because they have something in common. So these are not mutually exclusive events. Let's do an example on this rule. I have a couple examples, probably 3. Find the probability of rolling a number less than 3 or rolling an odd number. So less than 3, I'm going to call it A, and an odd number, I'm going to call it B. One way you can do this, guys, you can figure out the outcomes. So we know it's out of 6. What are the numbers that are less than 3? What could you get for less than 1? Okay, less than 3 for A, it could be 1 or 2. What about rolling an odd number? What could you get if you roll an odd number? A 1, a 3, and then what? A 5. So what would be your final answer? Rolling a number less than 3 according to the rule, which is 2 out of 6, plus rolling an odd number, which is 3 over 6, minus, how much is the overlapping? How many values do they overlap here, guys?
1.
1 out of 6. And the final answer, guys, is 4 out of 6. Another way you could have done it, you can tell me, I want to count them, see how many altogether. So it's 1, 2. You already counted the 1. You don't count it twice. 3 and 4. Well, it is 4 out of 6. So this is another way to do it. That's the addition rule. There's another one. A frequency distribution shows the volume of sales in dollars and the number of months a sales representative reach each sales level during the past 3 years. If this sales continue at this pattern, what's the probability that the sales rep will sell between 75,000 and 124,999? So from here to there. Okay, how do you find this probability, guys? He says anywhere from 75,000 to 124. So if he sells between 75,999, that's good. Or if he sells between 100,000 and 124,999, that's good also. So it's either this or that. So that's an addition rule, guys. So what would be the answer for this? What's the likelihood? What's the probability that the person will sell between 75,000 and 999,000? It's 7 out of what? Can someone tell me? It's 3 years. So if you add those numbers, what do you think you're gonna get the sum? 36. 8, 14, 21, 30, 32, 35, and 36. So that's 7 plus over 36 plus. Now this person could sell between 100,000 and 124,000, which is a probability of 9 over 36. There is no overlapping here, so minus 0. They're mutually exclusive. It will be 16 over 36. Okay, that's another example. Now you tell me, how do these two values don't overlap? Look, this one ends at 99,999. This one starts at 100,000. They don't overlap. So there is nothing in common in between. There's another example. That's an important one, guys. When it comes to tables, we're gonna see that I'll put lots of tables there, ask you questions on probability. A blood bank catalogs the types of blood given by donors during the last 5 days. A donor is selected at random. What's the probability that the donor has type O or type A? So probability of O or A. Okay, according to the rule, guys, it says probability of O plus probability of type A minus probability of someone has in type O and type A. What is the probability of getting a donor who is type O? Now I need your help.
184.
184 divided by what?
409.
409. I agree. Plus probability of A. Someone was type A.
164 over
yes.
409.
Humana 164 over 409 minus. Is it possible to find someone who has blood type A and O at the same time? That's not possible.
No.
And you guys, you can see they don't meet. O goes vertical this way and A goes vertical. The only way for two things to meet if one was vertical and the other one was horizontal. That's a 0. You don't even need to mention it here. These are mutually exclusive. So the answer will be, guys, 348 divided by 409. Be careful. In my math lab, he might want a decimal. He might tell you 3 decimal places. Just to do the 3 decimal places, for example. So let me see here if I do 3 decimal places and write down the answer. 348 divided by 409. I got this. And this translates to 0.851 for 3 decimal places. All right. What's the probability that the donor has type B or negative? Okay, so that would, according to the rule, addition rule, it's probability of B plus probability of RH negative minus B and RH negative. Okay, help me out, guys. First one, what's the probability of selecting someone who's type B?
45.
45 divided by 409 plus RH negative
65 over 409.
is 65. Yeah, there's not many of type negative here. Minus the overlap. We cannot count things twice, so we have to minus it here. So how many patients overlap between type B and negative?
8.
8. I agree. 100%. And here you go, guys. It's 110, 102 divided by 409. And that's the answer. Let me just do it. It'll be about 25%. 24,249. All right, so that's, let me add one more question. C. Probability that the donor has type AB or RH plus. Okay, let's do it. Type AB. How many are there that has type AB? 16. You agree, guys? 16 over 409. Just to enforce the addition rule so you understand it well. RH plus, you always go for the totals, guys. For RH plus 344. Minus the overlap now, which is 12. And your final answer is going to be 348. Oh, it turns out to be just like the answer above, 0.851. That's, this is the addition rule. A verbal question, guys. What is the probability of selecting a donor who has type A and RH negative? And RH negative. So what's the probability of selecting a donor who has type A and negative blood type A? There's no addition rule here, guys. It's an and. So just figure out how many are A and negative. Well, 25 divided by 409. Exactly, as student says, 25 divided by 409. Here's another one. What's the probability of selecting a donor who has positive type? I didn't specify the blood type, just positive RH.
344 over 409.
Exactly, that's how you do it. Okay, let's add one more now, conditional probability. Pay attention to this, that's conditional now. What's the probability of selecting a donor who has type A given that the donor has an RH positive? So type A, if you want, I can write it down.
Is it 139 out of 344?
Actually, I forgot what I said, so let me just type this, put this here. D, probability of selecting type A donor given donor is RH plus. All right, let's see. So remember, guys, what I said yesterday, what comes after given goes to the denominator. So how many total RH plus? We have 344, you're correct. Now the numerator is easy, guys. Figure out how many are type A and the plus at the same time. So it's the overlap. This is type A, this is the plus, it's 139, that is correct. And the answer will be 139 over 344. So remember, guys, when we give you conditional probability, the denominator will change. It will not be the grand total anymore. All right. And now the last part, which is section 3.4. It's just very basic stuff in 3.4. We're not going to go into depth, just basic knowledge. So let me introduce this and tell you what 3.4 is about. There we go. I have 4 letters, A, B, C, D. Here's the task, guys, for you. You're gonna help me with that. In how many ways I can select 3 letters? Order is not important. Meaning, If you select the letter ABC, it's the same thing as ACB, as long as you give me those 3 letters. So can you guys help me figure out how many ways? Let's say these are 4 students, and I want to see in how many ways I can select the groups of 3 students. Can you help me figure out the answer? Let's do it. What would you select first? What's the first group? You can type it. ABC is 1. All right, give me some more.
ACD.
BCD is 1. More.
ACD.
DCB, okay, I saw a student says DCB. DCB, guys, is the same thing as BCD because it's the same letters. Order is not the same, but we say the order is not important here.
ACD.
ACD, good. CDA is the same thing as ACD. Oh, I have ABD. A student said, Julia says ABD. She's right. Can you come up with more, guys? It's impossible. That's it. There are 4 ways when the order is not important. But imagine, guys, giving you this question on the test. Instead of 4 letters, I give you those letters. I'm sure you'll write to the president of the college if I make you do this. You have those letters, and I ask you to do this by hand in how many ways you can select the 3 letters. Do you guys agree with me? It's a lot of work, correct? And be honest with you, if you do this by hand, I can guarantee to you, I can say with 99% confidence that you're gonna miss so many combinations. So the reason why I'm saying that, there must be a nice formula that you can use to figure out the answer. So let me introduce the formula. You already know if you have 4 items and you wanna choose the 3 items, there are 4 ways only. And let me show you how the formula works. Okay, I'll write it down and then I'll explain it. N is how many you start with. So we started with 4 here. C is for combination or choose. And R, I wanted 3. So in how many ways I can choose the 3 items out of a set that has 4 items. Here's the answer, and then I will explain it in a second. This is an exclamation mark, but it doesn't mean an exclamation mark in mathematics. Okay, let me explain what we mean by the word number n factorials. N factorial, it's factorial, guys. It's a pronounced factorial. So it's n factorial means 1 times 2 times 3 times 4 times 5 all the way to n. Let me give you examples. Like if I ask you to do 4 factorial, it's 1 times 2 times 3 times 4, which is 24. 3 factorial, guys, means 1 times 2 times 3, which is 6. 1 factorial means 1. 0 factorial, for information, it's also 1. So this is what factorial means. Your calculator can compute this, and actually your calculator can do this formula. I'm going to show you in a second. But I'm just going to show you that this formula works. In our case, n was 4 letters, and we need to choose 3. So let me replace n with 4 and replace r with 3. Okay, guys, what's 4 minus 3 here? 4 minus 3 is 1 factorial. Watch. 4 factorial means 1 times 2 times 3 times 4. 3 factorial means 1 times 2 times 3, and 1 factorial means 1. Well, if you guys do the math, you know what you're gonna get. There you go. We got 4 here. So the answer is 4. Now get your calculator ready and let me show you how to do this on the calculator. 4, choose 3. Here's how you do it on the calculator. Under resources by your instructor, you will have a handout showing you also how to use the calculator in chapter 3. So you'll see that, but I'm going to demonstrate that. There is not much there, guys. So watch. If you have your calculator handy, just put a 4 on the home screen. Click on math. Click on probability. This is a chapter on probability right here. Move over to probability. And you guys, I think you can see what I'm hinting to. It's Ncr formula, so it's number 3. And now the calculator needs to know how many are you selecting from the set of 4. You need to type in the 3. And enter. You should not be surprised if you get the answer 4. That's a 4. Now we'll come back to the question that I asked you, which, to be honest with you, it will be almost mission impossible to do it by hand. You got how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. In how many ways you can select the 3 letters? Let's do it on the calculator. So you just put 19 on the home screen, and then you go to math. And watch how easy it is now with the calculator. Probability, go to this, 3. 969. So imagine, guys, you were gonna list 969 ways. You're 100% sure you will miss so many. It's 960 ways to do that. So this is called the combination formula. And this formula, we use it when the order is not important. Now, maybe a question you'll ask me, how do we know if the order is important or not? The problem itself will tell you whether the order is important or not. Like, for example, if you're talking about finishing a race, well, the order is important, who finished first, second, third, fourth, etc. But when I say I want to select the 3 students out of a group of 10 students, you know, the order here is not important. So that explains the combination. And now we're gonna see how we can select R items from a set of N items when the order is important. Okay, let me do this example with you here. So this is called combination. Now we're gonna do permutation, and then I'll go back to the handout and fill in the blanks. Permutation means you have N objects, select R objects, but order is important. So let's do it again with the letters A, B, C, D. And I want to select 3 letters. Order is important, guys. Help me select them. Okay, let's do it. What do you suggest? In how many ways I can pick 3 letters out of a set of 4 where order is important now? So I'll start. ABC is 1. What's next? Yes? Need your help. Let me finish the ABC. Okay, yes, ABD, BCD, I agree. But let's finish the ABC. ABC, just work around those 3 letters. What about ACB? That's 1. Now you tell me that I have the same letter, but the order now matters, guys, because the way you select them, you could pick like a president of a club, vice president, and secretary. So A is the president, B is the vice president, C is the secretary. Here, A is the president, C is the vice president, B is the secretary. So things are changing. Here is BAC. Here is BCA. Here is CAB, and here is CBA. Oh, there are 6 of them, guys. Now go to ABD. You're gonna get 6. Then you told me BCD. you're gonna get 6. And there is one more, ACD, you're gonna get 6. So 6 plus 6 plus 6 plus 6, total of what, guys? Is 24. There are 24 ways to select a group of 3 letters from a set of 4 letters where order is important. Now, you don't need to do this by hand. There is a formula, and the formula reads like this. It's NPR. N and P stands for permutation. So N, it choose R, but the order is important. My N here is 4, guys, and my R is 3. And let me show you that you could have done this on the calculator. Let me show you how the calculator works. Okay. Put the 4 on the home screen first. And then go to math. And then go to probability. And then number 2, guys, you can see it's NPR. And then put 3. And you should not be surprised if you get the answer of 24. It is 24 because we did count to 24 in there. Here's another example that I really like a lot. I use this example a lot with students. Okay, you have a table that seats 10 people. Round table. Let's put 10 chairs there. 6, 7, 8, 9, and 10. Okay, you're inviting 9 guests to your house, and you're the 10th person. The question is, in how many ways you can seat 10 people around a table of 10? Remember, seating arrangements, the order is important because that's why they call it arrange the seatings. Then the order is important. My question to you guys, in how many ways you can do that? Can you guess it, first of all? Can you give me a guess? How many ways we can seat 10 people around a table of 10? Give me some guesses in the chat. Any guesses? 100. What else? Think about it. You're the host. Think about the table and how many ways you can seat people around the table. Like a person A sits next to person B to C, and then you change the seating arrangement. Okay, 150. Julia is going up 50. What else? Give me 2 more estimates. You guys, you're way underestimating in how many ways you can seat 10 people. You're gonna be surprised when you find out what the answer is. Okay, watch. Let me demonstrate the answer and convince you that it is correct. Here's the table, empty. You don't have any guests. 1,000. Oh, still too much an underestimate. You will be very surprised to know what the answer is. Okay, but let me convince you without even knowing any probability here. I can convince you. The table is empty. The first guest arrives. Do you guys agree with me that the first guest has the choice to sit anywhere he or she wants? Yes or no? So how many choices does the first guest have? Yes, 10. Okay, let's give this guest a 10 choice of 10. He or she can sit anywhere, 10 choices. Then 2 minutes later, the second guest arrives, knocks on the door, come on in, seat anywhere you want. How many choices does the second guest have? 9. Then the third guest arrives, and you guys can guess what I'm gonna put there. 8, 7, 6 choices, 5, 4, 3, 2. They're seated. Now the host comes and sit down. Well, the host has no choice but one seat left, so he only has one choice. Remember yesterday, guys, here we have 10 events because I have 10 guests, so it's 10 events. To figure out, just the total number of outcomes of 10 events, we multiply the outcomes. So we see how many ways can event 1 happen, how many ways event 2 happen, 3, 4, and then we multiply. So I have here 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is, guys, 10 factorial. And let me show you how to find 10 factorial as an answer. Actually, guys, you thought it was 100, 150, or 1,000. It's going to be in the millions to see 10 people. Watch. This is a permutation. The order is important. I'll show you how to do it also using the NPR. But let me show you how to compute 10 factorial. Just put 10 on the screen here. Go to math. Go to probability. And then this is the factorial right here. And see what the answer is, guys. 3,628,800 ways to seat 10 people around a table of 10. Maybe it's just say, who cares how they seat? But if the arrangements are important for your information, this is how many ways you can do that. So it's about 4 million ways of doing this. Now, since the order is important, how people set, if the order is not important, guys, the answer is 1. There will be only one way to seat 10 people around that. They can sit anywhere they want as long as they use the table. So the answer will be 1. But the order is important here. You could have done this with the following way. You have 10 people, then you go to math, probability, NPR, and we want to seat them around a table of 10. So in how many ways you can seat the 10 people around a table of 10? And the answer is going to be exactly the same as this one. 3,628,800. So I'll go back to my handout and write the formulas for permutations, NPR. You really don't need to use the formula, guys, if you know how to use the calculator, which I demonstrated, but that's the formula. And for NCR, order is not important. This is the formula. Okay. Let me do this example here. 43 race cars started the 2007 Daytona. In how many ways can the cars finish first, second, and third? The question for you guys, is the order important here? Yes or no? Let me see what well, I'm glad you said yes. Yeah, that's actually, the race is about the order. Who comes first, who comes second, who comes third. So the order is very important here, the ranking. So that will be a P, guys, not a C. So in order to answer this question, we know it's a P, it's not a C. I have 43, select 3, because we want the first 3 places. Okay, if you have your calculator, guys, I'm gonna pause for a few seconds and let you do it. Okay, here's how you do it, guys. You put 43. Oh, do we have 43 first? Yes. You put 43 on the home screen. Then you go to math, prop, NPR 3, and the answer is 74,046. Let's answer this example, guys, as well. The objective of a 9x9 Sudoku number puzzle is to fill in the grid so that each row, each column, and 3x3 grid contain the digits 1 to 9. In how many different ways can the first row of a blank 9x9 Sudoku grid be filled? Let me just do the grid, guys. One, two, three, 4, 5, 6, 7, 8. Okay, we exaggerated here. Okay, we don't need this. Okay, that's the grid. Okay, does anyone know how to do this? In how many ways you can put the numbers 1 through 9 in the grid of 9 that has 9 boxes? What do you guys think the answer is? There are so many ways, guys. So many ways. Any ideas? The chat box is not active here yet. Values. So for number 1, the probability of throwing 1 dice and getting a number greater than 4 is 2 out of 6 because 5 is bigger than 4 and 6 is bigger than 4. 2. What's the probability of throwing 2 dice and getting a sum of the following numbers greater than 10? I'm going to change it because greater than 3, it's a lot of work. Okay, the denominator, guys, is 36. When you have 2 dice, it's 36. 6 times 6. Okay, give me the order pairs that could lead to a sum greater than 10. So greater than 10, 11 or 12. What are the order pairs that will give us 11 or 12? 5 and 6 is 1. 6 and 5 is 1. And there is one more for 12, guys, which is what? 6 and 6, yes. So how many altogether? 1, 2, 3. They're not 6, guys. Some students will count them 1, 2, 3, 4, 5, 6. No, order pairs because we're doing 2 actions at the same time. So that's the 3 out of 36. What's the probability of flipping a coin and getting the head 5 times? That's a good question. What's the chance, guys, that you flip a coin and get the head every time for 5 times? It's going to be very low probability. It's not going to happen, guys. Unlikely to happen. But what is the chance of this happening? Maybe you'll ask me why I put 5 fractions there, because I have 5 actions. Remember, probability, and these are all independent actions, so you just multiply the probabilities. What is the probability of getting a head when you flip a coin? A half, okay. And it's gonna be a half in the second trial, a half in the third, a half in the fourth, and a half in the fifth. You just multiply half by half by half 5 times. And the answer, guys, will be 1/32. For your information, when the probability answer is less than 5%, we say it is unusual probability. If it is 5% or more, we say it is usual probability. Okay, let's see number 4, guys. Customer wants to buy a bread in a can. There are 30 pieces of bread in the shop, including 5 from the day before, and 20 cans with unreadable expiration date, of which one has expired. So one expired and the 19 did not expire. What is the probability that the customer will buy a fresh bread and a can under warranty? And, okay. I'm ready, guys. How would you figure this out? There are two actions at the same time. Remember, it's you're buying a bread and you're buying a can. And since the events are independent, but the bread has nothing to do with the can, you multiply the probabilities. So you guys have two fractions that you have to figure out and multiply them. So let me make it easy on you. What would be the probability of buying a bread that is a fresh bread? Yes? You got 30 pieces of bread. 5 of them are not good. Yeah, 25 out of 30. Very good. 25 good divided by 30 times. What's the probability of buying a can that is not expired? Yes, 19 over 20. Multiply. Let's multiply them and see what the answer is. We multiply them because when two events are independent, guys, the probability of the two events together is the probability of the first event times the probability of the second event. So 25 over 30 times 19 over 20, I get 0.792. Okay, let's do number 6. We have 100 tickets and the hat numbered from 1 to 100. With what probability we'll pull out a number that is divisible by 5? So what's the probability that you pick a number divisible by 5? You have 100 tickets here. How many numbers between 1 and 100 are divisible by 5? For a number to be divisible by 5, guys, it has to end with a 5 or 0. So how many are there? Can you tell me? $20? Yes, you are correct. 5, 10, 15, 20, 25, 30. I'm going to list them for you. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. If you count them, guys, it's 20. So the answer is 20 out of 100. That's how you answer this one. 7. Johnny wrote a random number from 1 to 20. What's the probability that he'll select a prime number? So you have 20 numbers there. A prime number is a number that's divisible by 1 in itself only. So can you list the numbers between 1 and 20 that would work on your favor of finding the answer from 1 to 20, guys? Prime numbers. 1 is not a prime number for your information, guys. So 2 is the first one. 3, 5, 7, 8 is not, 9 is not, 10 is not, 11 is, 12 is not, 13 is, 14 no, 15 no, 16, 17 is, and 19. So 1, 2, 3, 4, 5, 6, 7, 8. Good chance. 8 out of 20. And I like you to do the rest of those, guys. I'll provide the solution to this one as well along, just with the handouts, but just give you a chance to work it out. What I'm gonna do now, I'm gonna stop the recording and then share the test, the practice test with you.